Welcome to Marker Board Videos. Today's video is on balancing chemical equations. When you see a chemical equation that you need to balance, usually it's written like that. First step in balancing it is to actually give yourself a little bit of room to write. So I like to rewrite my equation, putting blank lines in front of every element or compound in the products and on the reactant side. The reason that I do that is that helps me remind me that the only numbers that I can change are numbers that I put on that blank line. This little number here, this 2, that's called a subscript. And you can't change that when you're balancing chemical equations. You can only change coefficients. These little blank lines are where the coefficients go. And right now, there's a number on each of those lines. It's invisible, but it's there. That number is 1. It's 1. So the way I balance chemical equations is I make myself a little T-chart. I ask what's on the left side of the arrow and what's on the right side of the arrow. You can list this as products and reactants if you want. I choose the right, left, and right just because it helps me keep it straight in my little brain. And then I write what elements or compounds I have. I have potassium and I have bromine, and that's all I have in this equation. Now I start counting. How much potassium do I have on the left? I have 1. It could be 1 mole, it could be 1 atom, depending on the size of your equation, but we're going to say 1 mole. I have 1 mole of potassium, I have 1 mole of potassium on the right. That's what I want to see. I want to see the same number on the left and on the right. How much bromine on the left? 2. How much bromine on the right? 1. Well, that's an issue because I need to have the same on both sides. And if the only numbers that I can change are the coefficients, and this is a 1, if I want to double my amount of bromine, I simply make that a 2. But in chemistry, when you change one thing, you change everything. So we have to go back to the beginning. Potassium on the left, 1. Potassium on the right, 2. Again, I have an issue. Not a big issue, because I can change my coefficient. And if I change that coefficient from the invisible 1 to a visible 2, now I can redo this. Potassium on the left, 2. Potassium on the right, 2. That's good. Bromine on the left, remember it's 1 times 2. You don't have to write that 1, but it's there. 1 times 2 is 2 bromines on the left and 2 bromines on the right, and my equation is balanced. Not every equation that you're balancing is going to be quite that simple. Here's an equation with polyatomic ions. I treat polyatomic ions frequently as if they were one thing, and I'll show you what I mean in a minute. Let me write the equation down here, plus KNO3. The first thing that I do is I look at this equation and I ask myself, is NO3 together as NO3 on both sides? And it is. So I put parentheses around this NO3. That's just to remind me I'm keeping it together. And the same thing with the PO4. Alright, so now I make my T-chart. Left, right, or products and reactants. And what materials do I have? Well, I have calcium. I'm going to keep NO3 together. And the reason I'm keeping it together is because I have it on both sides of the equation. I have potassium and I have PO4. I also put it in parentheses just to remind me to keep it together. So I didn't draw my little blank lines here because I don't really have enough space on my board, but you know that they're there. Again, those lines are the only place I can make changes. How much calcium do I have on the left side of my equation? 1 mole. And on the right side of my equation, I have 3. I have 3 moles. So I have to put a 3 here or else there's no way I can get 3 on both sides. So 3 calciums on the left, 3 calciums on the right. Now NO3. Again, we're talking about this whole thing as being 1. So this tells me I have 2 of them, and then I have 2 times 3, so I have 6 on the left. How much on the right? Well, on the right now I only have 1. So I want to make a 6. I'm going to throw a 6 right in there, so now I have 6 and 6. Did that impact my calcium? No, my calcium's still 3 and 3, so I'm good. Now let's look at potassium. Potassium here is 3, but here I have 6 potassiums. Oh, so how do I make this 6? How do I go from 3 to 6? Well, I'm going to put a little 2 there. 2 times 3 is 6, and that's 6. Okay, I don't have to re-look at the calcium and the NO3 because I didn't change anything. I can take a quick look. 3 and 3, 3 and 3, 6, 6, 6, 6. Now let's look at PO4. I have 2 PO4s on this side, and I have 2 PO4s on that side. That 2 was kind of hard to see. But I have 2 and 2. Now let's look at my numbers. I have 3, 2, 1, and 6. And that is my lowest whole number ratio, so that equation is balanced. Really important. One of the most important things you're going to do in chemistry when you're balancing equations is to remember to keep those polyatomic ions together if they are on both sides of the equation exactly the same. Now let's do a combustion reaction. we have C3H8 plus O2 reacts to form CO2 plus H2O. Alright, and as you know, that is a combustion reaction. It looks pretty easy. On the left, I have carbon, hydrogen, and oxygen. I have the same on the right. Now, I don't have any polyatomic ions on this, so I'm just going to leave it the way it is. Carbon on the left, 3. Carbon on the right, 1. So I'm going to change that right away before I even write it down. Now I have 3 on each side. And again, remember, you can only change coefficients. You can't change subscripts. How much hydrogen do I have on the left? I have 8. 8 atoms, 8 molecules, 8 moles, 8 whatever, but I have 8 on the left. And on the right, I only have 2. So to change that to 8, I'm going to have 4 of these little puppies called H2O, because each one of those looks like that. So if I had 4 of those all together, I would have 8 hydrogens. So 8 on the left, 8 on the right. Now let's look at oxygen. I have 2 on the left, but on the right I have 3 times 2, so I have 6, and then 4 times 1, so I have 4. So altogether I have 10 oxygens, but I only have 2 here. Well, if I put a 5 right there, suddenly that becomes 10, and that becomes 10, and that's my equation's balanced. My coefficients are 1, 5, 3, 4. And I always take a look at that when I'm done, and I make sure that that's the lowest whole number ratio. If it's the lowest whole number ratio, I'm good to go. Let's do one last equation. And this is a neutralization equation. Hydrochloric acid plus sodium hydroxide reacts to form water plus sodium chloride. I'm going to change my water. I see this OH right here, so I'm going to change H2O to HOH. Really important when you're balancing equations that you start to recognize things like that. I saw an OH, I'm going to put an OH there. Again, remembering that we can only change our coefficients, not our subscripts. And it looks to me like I have an OH on both sides. So let's put the OH in parentheses, and let's see if this works. Make my T-chart, left, right. I have hydrogen, chlorine, sodium, and hydroxide. I'm going to leave my OH together. I'm going to leave it together because it's on the left and on the right. How much hydrogen on the left? Now just hydrogen, not the OH. How much hydrogen on the left? 1. And on the right, 1. If you used H2O, you would have thought there were 2, and this would have been a very difficult equation to balance. But because you recognize that it's not H2O, if you write it as HOH, it becomes a simpler equation. Chlorine on the left, 1. Chlorine on the right, 1. Perfect. Sodium on the left, 1. Sodium on the right, 1. And hydroxide on the left, 1. Hydroxide on the right, 1. Do you see how easy it was? Totally balanced, actually. But you see how easy it is when you break your water down to HOH. Only if you have an OH on one side, you should make it as HOH on the next side. Please watch for part 2 of Marker Board videos, Balancing Equations.